Welcome to Renaissance Videos. Here again is the 4 dual-pole motor running in 24 volts. This time we have transistors on there, 4 of them, 1 per coil. Oops. So we have 4 motor coils, 4 generator coils that aren't hooked up at this point. And we have our opto board here. And we have a transistor and a 10-watt LED. We're not running this, of course, at full brightness or anything, but instead of using resistors, we're going to use this 10-watt LED. And so it will light up a little bit, and we'll get some light while we're running the motor. So we're going to do 24 volts charging as well. 24 volts input, and I was just a bit concerned whether this was going to self-start with the transistors, and you can watch the amperage as it gets started here, and you can just watch it for a second. So you can see it does pull a good 5 amps, 6 amps at startup, and the good part about this is it's a very strong motor, of course. It's a good charger as well, and it doesn't heat up is what I was after here. We have sufficient transistors here, even without a heatsink. We're not looking at even 1 amp. So we have a lot of power here. Now we can see the light. It's not extremely bright, but it's probably well, I can't even say the brightness. Just a little bit of brightness here for the night light, I guess you could say. Turn out all the lights here and see. So we have some light here. This is not what this video is about, of course. So now what we'll do is we're at 84 milliamps, or sorry, 840 milliamps, but so now we've disconnected it so you can see 840 milliamps. So when we put this load on, it's got decent torque without heating up the transistors. That's still extremely fast. This goes through several resonant phases on this rotor. So I'm loading it down as hard as I can squeeze. This is burning in my hand. Of course, this is not a proper load test or anything, but it gives me a relative idea. Again, I'm looking at, ouch, it's really hot, burning my hand. Anyway, what I want to do is look at the heat. So I can load this down to 1.5 amps at 24 volts. And of course, as we load it down, the charging rate goes up along with the amp draw. So we can look at the voltage on the input. Oh wait. So we're only at 24 volts input, and what we're looking at is, a fully charged battery bank here would be 25.2 or higher. So this is a decent charging system and motor application. I was putting a pot in series here instead of the bulb, and it gave me only a little variation. I would have to go up to a 2K pot. This is a 1K, 1000 ohm pot that we use in our kits, and it gives me some variation in the amps, but I figured for the customer I would give them the LED here so that they could have some useful extra energy. So this is satisfactory. So what you could do is unsolder these connections and use either side of the pot here, either two terminals to run, and then adjust it. But you got to be careful not to adjust it quickly under load, because you could burn these up. This is only a half a watt pot, so I was using a much bigger pot here to adjust on the fly. This was a 100 ohm one, or actually 300 ohm, and what I really needed was 1,000, actually 2,000 ohm. So that should be it for this. I don't really need a heatsink on this. We can go up to 36 volts if I put a regulator in here, because this is only, well, this could go up to 38 volts, this Hall sensor here. So we could actually still use this at 36 volts, but we'd want to create a different resistance here. Otherwise, it would be pushing it too hard. You'd want to go up to 3,000 ohm pot, 3K pot. So that is our demonstration here. So you can hear it wind down. You can see our charging bank. So it's sitting at 26.2. And then we'll go back down a little bit. And our other bank is sitting at 24.8. So again, in order to rotate this rotor in the direction you want, you place it slightly after top dead center to turn it clockwise here. If I wanted to turn it the other way, then I would put it there. Now we can put two, as I've shown before, and switch between them to rotate different directions. And where you want it also is just in front of the generator coil. There has to be a coil there, otherwise the spacing won't be right for the Hall, and the magnets are a little too powerful. So you can, if you push it too far forward, you're going to draw a little more amps than you want with less power. Put it too far back, then it will draw less. So you could actually vary this. We used to have a timing plate there, but it's kind of thick. So we just kind of make it like this. But you do want to put the hot melt glue on there. I didn't do this for this particular setup. And then, of course, here's the circuit, the basic circuit. And then we've got the diodes and resistors on the back there. So thank you for watching.